to the channel. You know the purpose of channel is to facilitate students in learning physics at their convenience. It is a class without a classroom, so learn physics at your convenience. Let us start our lesson. The topic is resistance and resistors. Look at this diagram. When we apply potential difference across a conductor, current starts flowing in it. Current is due to the flow of electrons or negatively charged particles. When these charges move through the conductor, they collide with each other and also with the atoms of the conductor. Conductor offers resistance. Conductor offers opposition to the flow of current. This opposition offered by the conductor is called resistance. How we define it? The opposition offered by a conductor to the flow of charge through it is called resistance. Students, by Ohm's law, we know that the voltage across the conductor is equal to current through it multiplied by R. R is called resistance, the opposition offered by the conductor to the flow of charge. Rearranging this equation, we get R equals to V over I, where R is called resistance and it is the ratio of potential difference and current, voltage across the resistor and current flowing through it. The unit of resistance is volt per ampere called ohm. Ohm is the unit of resistance and 1 ohm, this is the symbol for ohm. 1 ohm is equals to 1 volt divided by 1 ampere. Means if we apply 1 volt potential difference across a conductor and there flows a current of 1 ampere through it, then its resistance will be 1 ohm. Students, on what factors the resistance depends? Number 1, the resistance of a conductor depends upon its length. How it depends upon its length? More is the length, more will be the resistance. Less is the length, less will be the resistance. So a long wire has more resistance than a short wire. Number 2, the second factor on which the resistance depends is the cross-sectional area of the conductor. If we have two wires of same material having same length but different cross-sectional areas, a thick wire has less resistance. Charges can pass easily through a thick wire than a thin wire. So area of the cross-section is more, less will be the resistance, and thin wire has higher resistance. Next thing on which the resistance depends is temperature. Let us consider two wires of same material having same length, same cross-sectional area, but one is hot and one is cold. The hot wire has higher resistance because inside it the vibrations of atoms are more and they offer more target area to the flow of charge. So resistance of a conductor increases with its temperature. Hot wire has high resistance and cold wire has low resistance. And the fourth thing on which the resistance depends is the material of a conductor. Let us consider the wires of same length, same cross-sectional area and have different materials. Let us consider a silver wire, a copper wire, a gold wire and an aluminum wire. Their materials are different, so they offer different opposition to the flow of charge, means their resistance is different. The resistance in this case increases as we move up in the list. For example, silver has least resistance, then comes copper, then comes gold and then comes aluminium. So this is how the resistance change with the material of the conductor. So these are the factors on which the resistance depends. Students, at high school level, it is enough to discuss the resistor and resistance. A resistor is a substance that is used. Types of resistor. Resistor is a substance, as I told you, that is used to offer a specific amount of resistance in a conductor. They are of two types. Number one, fixed resistors. As it is clear from its name, the resistors whose value is fixed, whose resistance is fixed by the manufacturer. You may have seen components like this in your electronic devices. These are known as fixed resistors. The value of the resistance is indicated in the form of color bar codes. There are 4 strips, 3 on one side and one strip is at a little gap from these 3 strips. First strip indicates the value of first digit of the value. Second strip indicates the second digit, and third strip indicates the number of zeros, where fourth strip either golden or silver, or there will be no fourth strip. That shows the tolerance of the resistor. However, you will study these things in your college classes in detail. At this point, you should only know that there are two types of resistors: fixed resistors whose resistance cannot be changed, it is fixed by the manufacturer, and second type of resistors are variable resistors. These are the resistors whose values can be changed in a given limit. You may have seen this type of switch that we usually call dimmer. In your room, you use it to control the speed of your fan, ceiling fan. So this is a variable resistor. When you rotate this knob, actually you are changing the resistance of this switch. So it controls the flow of current in the wire. It is an example of variable resistor whose resistance can be changed in the given limits. Similarly, another type of variable resistor that we call rheostat. It is the variable resistor that we use in laboratories for controlling the current in a circuit. So these two are the examples of variable resistors. These are the resistors whose value can be changed in a given limit. Students, this is all about resistance, dependence upon the resistance, and resistors and their types. Students, thank you for sparing your time to watch this video. If you liked it, don't forget to subscribe the channel. Take care of you. Goodbye.